when we're solving inequalities, we often draw it on a number line. But of course, not everything has one variable. So when we have two variables, we end up with regions in the plane, so we put it on the number plane. So how do we attempt to draw a region? The first thing is to draw the boundary. Now the boundary in this case will no longer be a point, but it'll be a curve. So we draw that curve, and as I was mentioning yesterday, if the curve or the boundary is not included, we dot it. That's why we dot asymptotes. The same goes with the number plane and the boundary curves. If they're not included, we dot them. If they are included, then we draw a solid line to indicate, yes, the boundary is included. And I guess that's why if you go back to actual number plane graphs, when you think about it, the graph is just simply y equals. And that's why we draw a solid curve, because we're saying this line is included on the number plane. Now the point of intersection becomes interesting. How do we indicate whether that particular point is included or excluded? Same as we do on the number line. If it's included, then it's a solid dot. If it's excluded, then we just draw a circle. So it's a hollow dot, if you like. When do we circle it? If one of the boundaries is dotted, then the point of intersection is not included. For it to be included, both boundaries have to be solid. So anytime it's just dotted, we would have an open circle at the point of intersection. Then we calculate the region. Same as with the number line, we would test in between the points to see whether it's included. Well, we do the same here, but with the region. So we test a point that's not on the boundary. Let's do a very simple one to start off with. I guess these were probably the first ones we looked at, just a linear one. So y is less than x plus 3. So first thing we do is draw in the boundary. The line y equals x plus 3. In this case it's dotted because the boundary is not included. Now boundaries will always break things up into two pieces. We want to know which piece are we in. So we pick a point, but we make life easy for ourselves. So if we can include 0, we will. 0, 0, beautiful. We can do it with this one. It's not on the line. So if I substitute in 0, 0, is 0 less than 3? Well, yes it is. Therefore, we're on the right-hand side of this boundary. So that's the area we shade in. A circle, x squared plus y squared is greater than or equal to 9. So this time the boundary is included. Again, it breaks it up into two sections. This time we've got inside the circle and outside the circle. Okay, 0, 0, beautiful, I can use it. It's not on the boundary, so let's sub it in. Is 0 greater than or equal to 9? Well, no, it's not, so we're on the outside of the circle. That's the region we're talking about. Square root becomes very interesting here. Y is less than the square root of 4 minus x squared. Well, the boundary in this case is the semicircle. Y is equal to the square root of 4 minus x squared. But at this stage, we haven't split it into two sections, because it could just fall out underneath here and go around. It really is still just one region. Is 0 less than 2? Well, yes, it is. So I do know I'm inside the semicircle, but that's what I'm saying. What happens below the x-axis? That is what we do. Because remember, with this one, we have a domain. You still cannot substitute in anything bigger than 2 or less than negative 2. It's not in the domain of this function. So it would be impossible to put those points in and get an answer. Now, if you think of between those 2 points in the domain, if we're substituting and we get a negative is always going to be less than the positive square root of something. So they would be included. So basically, what we draw is these lines that are the endpoints of the domain. And that's how we end up breaking the number plane into two sections. So we're either, well, I guess you'd call it an arch. We're either inside the arch or outside the arch. And we've already worked out we're inside. But there's one more thing I should do. Because notice this. The boundary underneath is a solid line, whereas the semicircle is a dotted line. Why is this a solid line? Because it works. Anything underneath is going to be negative. So in this case, it is included. Pick any point you like. Let's pick the point 2, I don't know, -5. 2, -5. if you test that, -5 is less than, well, it would be 0. So that is the line. Well, we now have a dotted boundary meeting a solid boundary, so we should be circling those points of intersection to indicate they're not included. And if you're unsure whether they're included, again, substitute in. You've got the point 20. Is 0 less than 0? Well, no, it's not. It's actually equal to. So it's not included. It doesn't satisfy that inequation. What if we have two different curves acting as the boundary? I've got a parabola and I've got a straight line. Do them a piece at a time. So the first one, y equals x squared. It's solid because it's equal to as well. So there it is. Yes, it breaks it up into inside the parabola and outside the parabola. Because remember, that's going up to infinity. It's not going to spill over the top of the parabola. Test a point. I can't use 0, 0 this time, it's on the boundary. So I just need to pick a point that I know definitely its location, so I get the answer. I chose 0, 1, because I know that's inside the parabola. I can see that quite clearly. Sub in, is 0 less than or equal to 1? Yeah, it is. But in this case, I don't shade in yet. I just mark some crosses. I might have exaggerated them a bit there. So I know, all right, I'm on the inside. I'll put some crosses there, and that's what I'm talking about. Now I'll go do the other one. It's a straight line. There it is. Y equals 3x plus 4. Again, it's solid because it's included. Are we on the left side or the right side of that line? Another thing I guess I really need to know is, what are the points of intersection here? They're going to be useful things to know if I have to use this to solve problems. We would solve them simultaneously to get that, and we know, okay, that's at x equals -1, and the other one is at x equals 4. So there's the 2 points. Okay, so now I can work out the location of any point I'm going to test. Well, 0, 0. Let's test it. 0 less than or equal to 4? Yes, it is. So now I'll put some crosses there. So the region I'm talking about, where do I have both blue crosses and red crosses? Well, in there. So that's the section we're talking about. Technically, I should now go and dot the part of the boundary that's not included, because the solid line is saying, hey, it's included. Anything that extends beyond my region there, I should dot in to say, hey, not included in my solution. Okay. 3.